So in this question 2, this is about activated charcoal. So you will have heard of activated charcoal. They I forgot what they call it already in O-level, but they use activated charcoal to remove the odor from drinking water. In this case, it can also be used to remove impurity from mixture. This is called adsorption. It's not AB, it's AD. Particles of the impurities adsorb or they bond to the activated charcoal surface. Okay, so this is done through bonding to the surface. You want to determine the ability of the activated charcoal to adsorb a blue dye from aqueous solution. You are given this equation. So this looks like y equal to mx plus c to me. In fact, I think it is y equal to mx plus c because that is your y. C being your y-intercept. So you know your linear straight line equation from your, I don't know, lower secondary, upper secondary mathematics. That is your gradient, which is m. Well, I mean m in this expression, but they put down b as the value there. And there's a constant because the gradient is a constant in this straight line graph. Well, constant as in the gradient is fixed, all right? The a is the y-intercept, is a constant. And then this thing there is your x-axis. Well, your x value, not just x on its own, but you know, x-axis in the sense that it's your independent variable. Okay, whereas your y-axis is what you measure, which is your dependent variable. Okay, enough on that. You gotta be careful about the units. So this is gram per dm cube. So gram per dm cube of a gram. So this value will have per dm cube. And then this is your concentration, but it's in gram per dm cube. It's not in mole per dm cube. All right. So the student use the following procedure. Investigate whatever they want to investigate. First of all, you place a 50 cm cube sample. So this is a volume of this concentration, but be careful, this is to do with mass concentration. This is not molar concentration. You weigh some activated charcoal and you add it to the flask. You stir it for 3 minutes, leave it for 1 hour. Then you filter. So filtration is a concept of separating technique that you did in GCSE and O-level. And then we determine the final concentration by this thing called colorimetry. Okay, you have heard of colorimetry to monitor rate of reaction, especially in reaction that has color changes. We use colorimetry in transition metal chemistry as well to determine the stoichiometry of complexes with ligands. And then we repeat the procedure, okay, with different masses of activated charcoal. So you repeat all of these, but you use a different weigh mass of the activated charcoal. So I guess the most important step here really is this thing. You add in the charcoal, you stir it 3 minutes, you leave it for 1 hour, filter it to remove the insoluble activated charcoal, and then work out the final concentration of the blue dye by colorimetry. So this is to do with the adsorption of the blue dye onto the charcoal. Okay, so the adsorption of the blue dye onto the charcoal. So you're given a table now. You got to process the results to complete the table. You need to record your data to 2 decimal place. All right, so make sure you know 2 decimal place, just in case I forget. All right. Initial concentration of the blue dye, final concentration of the blue dye. So this is talking about the difference in concentration. You started with this, you end up with much lesser because most of them had adsorbed onto the charcoal. Most of them had gone away because most of them had bonded to the surface of the activated charcoal. So the difference here really is if this is A, this is B, this is A minus B. Okay. And then the next bit is they just want the log of X, so that's just log of B. Okay. I mean, it doesn't make much sense here, but anyway, I better write that out just so you know what is going on. Let's just start pressing the calculator. So you see this is all 25. So it's 25 minus this, give you this, 25 minus this, give you that, etc, etc. So 2 decimal place, yeah, 24.04. So this is the first one that your calculator shows you 24.4, and if you are careless, if you don't remember that you're supposed to put all your data to 2 decimal place, then you know you will lose an easy marks just like that. Okay. This is another one where your calculator shows 24.8. You gotta put a 0 to make it 2 decimal place. You're gonna take a log of this value. So there's log 10. It shows a negative 0.02 because we want 2 decimal place, not 2 significant figure. So be very careful. Minus 0.16. Did I write that right? 39. Okay. So log 0.33. So this one is another one. Be very careful. 2 decimal place is 57 because I read it as 0.5686 on my calculator. So 2 decimal place is minus 0.57. There is minus 0.64. This is another one. Be very careful. So 2 decimal place 0.70. This is 0.77. Okay, so I guess for 3 marks it's not so bad, just filling in the table. Try not to make any mistakes, and 2 decimal place is one of those things that people can make a mistake in. So you know, what's the point of me writing 2 decimal place there if I'm not gonna remember doing it, right? That's why we read the question. By considering the data in the first 3 columns, what is the effect? So you just need to state, okay, and they do ask you to explain later on, but what is the effect? Increase the mass of charcoal on the amount of adsorption, okay? On the first 3 columns, so it's this, and this, all right? So as the mass of activated charcoal increase, do we see what happened to the blue dye being adsorbed? So we see, actually they said the first 3 columns, but if you compare these two, it's very hard to see. You should use whatever you have calculated, which is the difference in concentration. So it started with 25, you end up with this, meaning this much has gone onto the charcoal. So this is however much had adsorbed onto the charcoal. So with more charcoal, there is more blue dye that had been adsorbed. Okay, how you can see that? As there are more and more activated charcoal, there is more and more blue dye that had been adsorbed because you get lesser and lesser final concentration of blue dye, alright? But I did say by considering the data in the first 3 columns, right? So as the mass of activated charcoal M increases, the final concentration of the blue dye decreases, and then you have constant initial concentration of the blue dye. So I've used the first column there, I've used the second column. The initial concentration of the blue dye was constant, but the final concentration of the blue dye decreases. So I still haven't answered the question. They want the amount of adsorption that occur. So the amount of adsorption increases because I get lesser and lesser blue dye in the end. So that means more and more of the blue dye have bonded to the activated charcoal surface. Okay, so why is that? Okay, so if we have more, so we're talking about bonding of the blue dye onto the surface, right? If we have more charcoal, if greater mass, then we'll have more charcoal, then we would have more of the solid surface on which the blue dye can absorb or bond onto. So obviously the amount of absorption would increase. All right, I hope that makes sense. With increasing mass of the activated charcoal, so we have more activated charcoal particle, therefore more surface area of the solid onto which the blue dye can bond, or the word they use was adsorb. In fact, they use bond and adsorb if you bother to read the equation earlier, where the particles of the impurity bond or adsorb to the activated charcoal surface. See that? Okay, so I mean that was like the third line of the original question, so you're supposed to read through that first. Bond or adsorb to the surface. All right, so I talked already about the surface onto which more of the blue dye can bond or adsorb to. Okay, plotting a graph, as we mentioned, that was your x, that was your y-axis. I don't necessarily want to call it x because you already have x there. Use a cross, so do not try and use a dot. Draw the straight line of best fit. I'll have my table of results open up on another piece of paper because I cannot bother to keep on going back and forth because it will make me dizzy. It will make you dizzy looking at the screen as well. This is the part that I mentioned at the start of the tutorial. Do not just watch me plot it. Grab your piece of paper and plot your own graph and see if you can complete it in the time that I've taken to complete it. It's not as easy as it seems, alright? So it's something that has to be done with practice, alright? So if you don't practice drawing it now, you're going to struggle when you sit for the actual paper. Trust me, okay? Try a practice paper and see how long it takes for you to put in the point, yeah? Do not skip this step, alright? So I'll get started. My first value, so this is log x. My first value is minus 0.02, so it goes backward. 0.02 is there. My y-axis is log d over m. So 2.08, 2.08, so that is minus 0.02. This is 2.5, 2.05, 6, 7, 8. So that is minus 0.02 and that is 2.08. okay. I'll probably plot the rest in silence now. Minus 0.16 and 1.99, minus 0.16, minus 0.16 and 1.99, minus 0.16 and 1.99, minus 0.22 and 1.91, minus 0.22 and 1.91, minus 0.39 and 1.85, minus 0.39 and 1.85, minus 0.48 and 1.79, minus 0.48, so 0.48 and 1.79. Okay, 0.57 and 1.74, 0.57 and 1.74, 0.64 and 1.69, 0.64 and 1.69, 0.70 and 1.65. That's the easy one. 0.77, 1.62, 0.77, 1.61, 1.62. All right. So I don't know how long that took me, but I hope you can see. I can draw this on my screen. So don't do what I do. Use a ruler, okay? But then I can do it on my screen because you see, if you have a ruler, you can see like where are you going to, manipulate it so that you get the best fit straight line. If you go there, there's a lot of points that doesn't give you the straight line. If I go there, that is still just one point that doesn't go to the straight line. I should try and fit as many points as possible. So I'll go somewhere in between, okay? And I think I should probably, it was my bad actually. I should probably have extended it to I was gonna say I should probably extended it to find the y-intercept as well. So if you see like that and like that, so the y-intercept is somewhere there, just below the line. So there's no way for me to get it just from there on its own. Obviously this is not 0, 0, so you need to be aware of it. This is clearly the most anomalous point because as you could see, this is the only point that really stands out as being far away from the line, whereas the rest is very close to the line. This is considered very close to the line compared to this, alright? So already circle the most anomalous point on the graph, suggest a reason why this may have occurred during the experimental procedure, okay? So we can see that the anomalous point, okay, if you look back at it, it should have been here, but it is here, so it is below where it should be. It should have been there. If there's the x value, it should have been there. So this value recorded is below where it should be, all right? So we can say that the point there is below where it should be on the line. So when you think about anomalous result, it's important to just think about where it should be first, all right? So we're talking about the y-axis value. So the y-axis value should be higher, okay? So this value for the y-axis is lower than where it should be. So log d over m is lower than expected. You expect it to be on the line, but it's lower than expected. So what do we know? We can say that d is lower than expected, and it's all about suggestion, right? I'm just focusing on the d. Of course, you can focus on the m as well. D is lower than expected. What was d again? Gotta check back on the original thing. Even I forget about the d. The d is the difference in concentration before and after adsorption. So if d is lower than expected, it's got to do with one of these steps. And I think the most important step here would be here. Okay, so you do leave it for 1 hour. Okay, but then in that 1 hour, a different rate of adsorption might mean that some of them didn't get adsorbed. Okay, so D is the difference in concentration. Okay, so D is the difference in concentration between the initial and the final concentration. So lower than expected. So final concentration, initial concentration minus final concentration, that is your D. So if that is lower than expected, your initial concentration is constant. Remember, you started with 25 for all your table. All of them are constant. So it's got to be this that is changing. So if we want D to be lower than expected, so that is 25 minus something, that will be lower. That means the final concentration of the dye is higher than expected. And why is the final concentration of the dye higher than expected? Perhaps did not live long enough, i.e. not the full 1 hour for adsorption to occur. Remember, you stir for 3 minutes and you left it for 1 hour. So this could be one of the experiments where you take it out before 1 hour. So your final concentration is higher than expected. Then this minus higher will give you lower, and therefore log D over M will be lower, and that's why your anomalous point is below on the line. Okay. Of course, you can also talk about the other thing, which is to do with the mass of the activated charcoal. So in order for this to be below, so that is lower. So your M is you can talk about the M essentially. All right. So what else is there? Log D over M. So log D over M is positive. I guess if you talk about the M, if you want it to be lower, then your M would be higher. I guess your M would be higher, and M is the mass of the activated charcoal. So you might have used too much of your activated charcoal. They will give you the log D over M to be lower than expected. Okay, so there are various things you can talk about really in terms of discussing anomalies. All right. Now you gotta use your graph to determine the gradient of best fit line. So modern papers always ask you to state 2 coordinates. And then this constant B is your gradient, remember? Y equal to mx plus c. Was it? Let me have a look. Yep, this is your y equal to m x plus c. So when you work out the gradient, that is the value of b. Okay, so b is your gradient. So if we look at our graph does not cut through every single point. So we need to choose our 2 coordinates very, very carefully. If I were you, I would go for this coordinate, which is minus 0.88 and 1.55. Nice and easy then. And then I can go for this, which is nice and easy as well. That is 0.00. So 0.00 and 2.05, 2.06, 2.07, 2.08, 2.085, 2.085. So 0.00 and 2.085. And the other point was minus 0.88 and 1.55. So working out the gradient, make sure you use bracket, because here we have a negative value. So if we run our final value to, they did ask us to put all our values to 2 decimal place here, right? So I guess it would be sensible if I use 2 decimal place instead of significant figure, just to be consistent with what they asked us to do previously. So I suppose I could get it to 2 decimal place. That would be 0.61, 2 decimal place. But before I run it up, I always show it to a slightly higher precision, yeah? So that is 0.6. Do I want 2 decimal place? Okay, maybe that will be alright, okay? So 0.61, and b is also the gradient, based on what we say about y equal to mx plus c, so that's 0.61 as well. Use the graph. Oh my god, this is difficult. So you gotta use the graph. So remember, A is your y-intercept. Okay, so when we plot the graph, you see how it actually goes beyond the line. So it's a let me see log d over m. So if I'm to read from this graph, if I extend this a little bit, I would probably say that it's like two of these three, maybe three of these small squares. So there's 0, there's 1.51, sorry, 1.551, 552, 553. So we're looking at 1. Sorry, there's 1.56, 1.57. So we're probably looking at 1.54, perhaps. So around 1.54 or 1.535. So somewhere along that line would have been all right. And of course, your x-axis would be... No. I am totally incorrect. You know why? Because that is not the y-intercept. I beg your pardon. That is not the y-intercept. Because the y-intercept is where you cut the y-axis. You see, it's really confusing, right? I don't know why I keep on looking at that. I just remember y-axis is where you cut the y-intercept is where it has where x equal to 0. Okay, and in fact I have used it for my gradient calculation, so I could have just put down 2.085 as my y-intercept, because that is where x equal to 0. So 2.085. That was stupid of me. Anyway, so that was my y-intercept already, because I used it as one of my coordinates. So that is just 0.00, 2.085. So a equals to 2.085. If I want it to be 2 decimal place, I can just not 2 sig fig, but 2 decimal place, just to be consistent with what I've done. 2.09. So yeah, there you go. Nearly make that big mistake. Okay, so gotta remember what y-intercept is. That is where x equal to 0. So not necessarily where it cut that whatever y-axis they give you, yeah, but where it cut the x equal to 0, okay, which is the y-axis. That's it really. That's the end of this paper 5 tutorial. So